Hello everyone and welcome back to the Intermediate Algebra video lectures. Today we are going to be continuing our factoring journey into something called special factoring. So just as to get us started on what this type of factoring is going to involve, I'm going to bring you way back into the previous chapter into distribution and expanding and multiplying. So just kind of as a warm-up to get us started, what we're going to do is we are going to multiply each of these, starting with x minus 3 quantity squared. Now, for something like this, remember, you cannot distribute an exponent across a plus sign or a minus sign. So this is not going to equal x squared minus 9. What you have to do instead is you have to expand it, which means writing it as repeated multiplication, writing it as x minus 3 times itself 2 times. And then you can further multiply this by distributing. So x times x will give you x squared. X times negative 3 will give you minus 3x. Negative 3 times x will give you another minus 3x. And then negative 3 times negative 3 will give you positive 9. So when you combine like terms, you will get x squared minus 6x plus 9. Same thing for the next one. You cannot distribute an exponent across a plus sign or a minus sign. So this is not going to equal x squared plus 16. Instead, what you're going to have to do is you're going to have to expand it, which means writing it as repeated multiplication, writing this as x plus 4 times another x plus 4, and then finishing multiplying using distribution. So x times x will give you x squared. X times 4 will give you plus 4x. 4 times x will give you another plus 4x. And then 4 times 4 will give you plus 16. So then when you finish combining like terms, you will get x squared plus 8x plus 16. And then for this last one, when you distribute these two, x times x will give you x squared. X times 5 will give you positive 5x. Negative 5 times x will give you minus 5x. And then negative 5 times positive 5 will give you negative 25. And then when you combine the middle terms, 5x minus 5x gives you 0. So the middle terms cancel out, leaving you with x squared minus 25. Now remember, factoring is, in layman's terms, distribution backwards. So we're going to be taking expressions like x squared minus 25 or x squared minus 6x plus 9, and we are going to be factoring them to give us expressions like x minus 5 times x plus 5 or x minus 3 quantity squared. So these special products, when you do them in reverse, they're going to be special factoring. We're going to start with this last one. So if you take a look at the format of this last one, this x squared minus 25, you will notice that there are only two terms. There is an x squared term and there is a constant term. The big thing that you're going to notice with this last one is that there is no middle term. There is no x term. There is no term that contains just an x. And the reason is because the x terms canceled out. This is what is called a difference of squares. It's called a difference of squares because, first of all, subtraction is also known as a difference. And there are only two terms here, and both of them are perfect squares. X squared is a perfect square, and 25 is a perfect square because 5 times itself gives you 25. So this is a difference of two squares. And the difference of squares is actually how we're going to start factoring. You will notice that the reason why this worked out to x squared minus 25 is because if you look at the two polynomials being multiplied, they are both binomials that are the same in every way except the sign in the middle. So one of them is an x minus 5, the other one is an x plus 5, and that's what caused the middle terms to cancel out. So that is how you are going to factor any sort of difference of squares. So any polynomial that is in the form of a squared minus b squared is called a difference of squares because you have a subtraction of two perfect squares. So when The reason that you get the difference of squares is because the factors are opposites. So differences of squares are always going to factor in the same way. A squared minus b squared is always going to factor as a plus b times a minus b. These two factors are going to be pretty much the same except the sign in the middle. And it really doesn't matter if the minus sign is first or if the plus sign is first. One of them is going to be an a plus b and the other one is going to be an a minus b. So we're going to factor each of these. Now the giveaway for when you have a difference of squares is there is no middle term. The x term, or the term that doesn't have an exponent, is just missing entirely. So for x squared minus 4, you will notice there is no x term. We only have two terms. They are being subtracted, and both of them are perfect squares. X squared is a perfect square, and 4 is a perfect square. So that's how to look for differences of squares. If you only have two terms and they are both being subtracted and both of them are perfect squares, you have a difference of squares. So because we have a difference of squares, that means our two factors are going to be opposite. One of them is going to be, there's going to be an x here and an x here. One of them is going to be positive and the other one is going to be negative. And then what number times itself gives you 4? Well, 2 times itself gives you 4. So one of the factors is going to be x plus 2, and the other one is going to be x minus 2. We're going to do the same thing for this next one. Let's check to see if it is a difference of squares. First thing you'll notice is that there's only two terms. The two terms are being subtracted. And y squared is a perfect square, and 9 is a perfect square. So because there's only two terms, both of the terms are perfect squares and they are being subtracted, this is a difference of squares. So differences of squares always factor in the same way. Their factors are opposites. So there's going to be a y here, a y here. One of the factors is positive, the other one is negative, doesn't matter which one. And then what number times itself gives you 9? Well, 3 times 3 gives you 9, so one of the factors is going to be a y minus 3, and the other one is going to be a y plus 3. So I want you guys to try that for yourself. I want you guys to try the top two. Yes, 1 is a perfect square. You have to ask yourself what number times itself is 1. So I want you to factor each of the differences of squares on the top, the x squared minus 1 and the x squared minus 36. So go ahead and pause the video for a minute and resume when you're ready to check your answer. Okay, so for x squared minus 1, there are only two terms. The x term is completely missing. We only have a square term and a constant. Both of these are perfect squares because x squared is a perfect square and 1 is a perfect square, and they are being subtracted. So this is a difference of squares, and difference of squares is always going to factor in the same way. There's going to be an x here and an x here. One of the factors will be positive and the other one will be negative. And what number times itself is 1? Well, that is 1. So it'll factor as x plus 1 times x minus 1. Then for x squared minus 36, there's only two terms. The two terms are being subtracted. There's a square term and a constant term, and both the square term and the constant term are both perfect squares, so that makes this a difference of squares. So there's going to be an x here and an x here. One of the factors will be positive, the other one will be negative. And what number times itself is 36? That'll be 6. So one of the factors will be x plus 6, and the other one will be x minus 6. Keep in mind it doesn't matter which one went first, as long as one of them is a plus 6 and the other one is a minus 6. Now for the next two, the big thing you're going to notice that's different about these next two is that the leading coefficient is not equal to 1. You do not just have a 1x squared. And as long as everything involved is a perfect square, it is still technically considered a difference of squares and can still be factored the same way. So for 25x squared minus 16, you're going to notice that there's only two terms, and the two terms are being subtracted. Now 16 is a perfect square because 4 times 4 gives you 16. 25x squared is also a perfect square because, x squared is a square. But is 25 a perfect square? Yes, because 5 times itself gives you 25. So because there's only two terms, the two terms are being subtracted, and everything involved with those two terms is a perfect square. This is technically still considered a difference of squares. So this is how we're going to factor it. The two are going to be opposites. Now what goes here and what goes here needs to multiply to 25x squared. So what number times itself gives you 25? Well, that will be 5. So there's going to be a 5x here and a 5x here. One of the factors will be positive, the other one will be negative. And then what number times itself is 16? Well, that will be 4. So one of the factors will be 5x minus 4, and the other factor will be 5x plus 4. So then let's take a look at this next one and see if it is actually a difference of squares. So there's only two terms. There's a square term and a constant. The two terms are being subtracted. And 64 is a perfect square because 8 times itself is 64. And 49x squared is considered a perfect square. What number times itself is 49? 7 times itself is 49. So this is a difference of squares because there's only two terms. The two terms are being subtracted, and everything involved is a perfect square. So we're going to set up our factors. So we have a 7x here and a 7x here. One of the factors will be positive, the other one will be negative. And then what number times itself is 64? Well, that will be 8. So one of the factors will be 7x plus 8, the other factor will be 7x minus 8. Now, before we move on, I want to emphasize that this is a difference of squares. The difference of squares is factorable, and they all factor pretty much the same way. The sum of squares, like x squared plus 4, is not factorable because there are no numbers that multiply to a positive 4 that add up to 0. We looked at the sum of squares at the end of the last video. So a difference of squares is factorable because in order to multiply it to a negative, the factors need to be opposites. However, the sum of squares is not factorable. So just when you have two terms, make sure that the two terms are being subtracted before you dive into difference of squares. Because if the two terms are being added, it's not factorable. Now for this next one, at first glance, you notice that there's no x squared. 8 and 18 are not perfect squares. So at the moment, as it's written, this is not a difference of squares, even though there's only two terms and the two terms are being subtracted. So even though there are only two terms and the two terms are being subtracted, nothing involved here is a perfect square. So as it's written right now, you can't factor this as a difference of squares. But one thing that you should always look for first in any factoring problem, I don't care what type of factoring problem you have, you should always look for GCFs first. So you'll notice that both of these terms are divisible by 2. The 2 is the largest and only number that goes into both 8 and 18. And you'll also notice that both of the terms contain the same variable x. And since the lowest power of x that appears here is 1, your GCF is going to be a 2x to the power 1. So what I'm going to do first is I'm going to factor out my GCF of 2x, and then I am going to finish factoring. So I'm going to take the 2x out of each term first, and then finish factoring. So 8 divided by 2 is 4. 3 minus 1 is x to the power 2. And then negative 18 divided by 2 is negative 9. X to the power 0 cancels out. Now remember, whenever you take out a GCF, you are just going to leave it there. You are just going to leave it in the front, and it will just be part of your final answer. So I'm just going to leave this 2x alone, and I'm going to focus on factoring what's in the parentheses. So what's in the parentheses, there's now still only two terms. The two terms are being subtracted. 9 is a perfect square. 4 is a perfect square, and x squared is a perfect square. So this in the parentheses is a difference of squares. So because it's a difference of squares, they're going to factor the same way. Now what number times itself is 4? Well, that will be 2. So there's going to be a 2x here and a 2x here. One of the factors will be positive, the other one will be negative. And then what number times itself is 9? 3. So this is going to factor as going to leave your GCF of 2x where it was, so the GCF of 2x times 2x minus 3 times 2x plus 3, and then that is going to be your final answer. So the differences of squares will all factor pretty much the same way. The other types of special factoring were built off of the first two warm-up problems, and those are what are called perfect square trinomials. So in a perfect square trinomial, when you factor, and you're going to factor it like normal, the two factors are going to be exactly the same. And when you have any sort of repeated multiplication or any sort of two factors that are exactly the same, you can write it as an exponent. So when your two factors are exactly the same, you can write it as a single factor squared. So there's going to be two versions of the perfect square trinomial, and they're both going to be factored in relatively the same way. So one format of the perfect square trinomial is going to be a squared plus 2ab plus b squared. So it will factor as a plus b times a plus b, and because these two factors are exactly the same, you can write it as repeated multiplication, a plus b quantity squared. Now the other format for the perfect square trinomial is a squared minus 2ab plus b squared. So that is going to factor as a minus b times a minus b, and because your two factors are exactly the same, you can simplify it further as a minus b squared. Now, it is not required that you memorize these formulas. If you're a really formula-oriented person, it might be helpful and you might find it helpful, but these can factor pretty much the same way as we factored any other quadratic in the form of x squared plus bx plus c. The big difference here is that your two factors are exactly the same. And when your two factors are exactly the same, you can write it as a square. So what we're going to do is we are going to factor each of these. So for x squared plus 4x plus 4. So the leading coefficient here is equal to 1. So because the leading coefficient is equal to 1, that means there's going to be an x here and an x here. And we are looking for two numbers that multiply to the last number 4 and add up to the middle number 4. So that would be 2 and 2. So positive 2 and positive 2. And because your two factors are exactly the same, we are going to write it as repeated multiplication. So I'm going to turn this x plus 2 times itself into x plus 2 parentheses squared. Just make sure that the squared is outside the parentheses because that indicates that everything inside the parentheses is being multiplied by itself. So that will finish factoring as x plus 2 squared. So then for the next one, take a look at the leading coefficient. The leading coefficient is equal to 1. So because the leading coefficient is equal to 1, there is going to be an x here and an x here. And we're looking for two numbers that multiply to positive 9 and add up to negative 6. Well, the only way that you can multiply two numbers and have a positive product is if the two factors have the same sign. So either they're both positive or they're both negative. And to add up to a negative, both of the factors need to be negative. So negative 3 times negative 3 will give you positive 9. Negative 3 plus negative 3 will give you negative 6. So one of the factors is going to be x minus 3, and the other one is also going to be x minus 3. Because these two factors are exactly the same, I am going to write the repeated multiplication as an exponent. I'm going to write this as x minus 3 parentheses squared, remembering to put the squared outside the parentheses. So then that is going to be our fully factored final answer. So I want you guys to try these two for yourselves. The factoring is going to be pretty much the same as what we've done in previous videos. Just if your factors are the same, you're going to write it as an exponent. So I want you guys to give these next two a try, pause the video, and then resume when you are done working. Okay, so for this next one, because the leading coefficient is equal to 1, that means there's going to be an x here and an x here. And we're looking for two numbers that multiply to positive 49 and add up to negative 14. Well, the only way that you can multiply two numbers to get a positive is if the two factors have the same sign. And in order to add up to a negative, they both need to be negative. So negative 7 times negative 7 will give you positive 49. Negative 7 plus negative 7 will give you negative 14. And then I'm going to write this x minus 7 times itself as x minus 7 parentheses squared. So then for the next one, because the leading coefficient is equal to 1, that means there is an x here and an x here. And we are looking for two numbers that multiply to positive 16 and add up to positive 8. So since everything is positive here, both of these factors are going to be positive. Two numbers that multiply to 16 and add up to 8 are 4 and 4. And then because the factors are exactly the same, I'm going to write the repeated multiplication as an exponent. I'm going to write this as x plus 4 quantity squared. So that is it for the special factoring. The special factoring are the differences of squares and the two perfect square trinomials. In the next video, we're going to be taking a look at one major application of factoring, and that is in solving quadratic equations such as x squared plus 8x plus 16 equals 0. So that's what the next video is going to be about, so stay tuned for that. So thank you all very much for watching this video, and I will see you in the next one. Bye-bye.